All right, in this little video, we're going to calculate the required course to pass an aid to navigation some distance off of our beam. Okay, so while on a course of 066 PGC, the light bears 18 degrees on the port bow at a distance of 12.3 miles. What course should you steer to leave the light 4 miles on your port beam? We know that if something's going to be on our beam, it's going to be 90 degrees to our course angle, and that creates a right triangle. So what I'm going to propose we do is we solve this problem in 3 steps. So here are the steps, okay? I propose that we'll calculate the true bearing, or the bearing to the light. In this case, it's going to be a gyro bearing. And then we're going to calculate the angle that we should be away from that light using trigonometry. Since it's going to be a right angle, we can use sine, cosine, or tangent. And then we'll apply the angle that we calculate to the bearing. So first thing I'm going to do is I'm going to draw just a rough picture just to get an idea of what we're dealing with. So, I'm going to assume that that's north, that's east. So if that's east, 066 should be, something like this. This is close enough, okay? So that's 066, that's my course. And I'm going to just lay my pencil down along my course, and they say, okay, well, the light should be on my, the light is currently on 18 degrees on my port bow, so that should be over this direction. So what I'm going to do now is I'm just going to draw another line here, and I don't have to be too crazy. I'm just going to, that's a light, whatever. And here we go. This is 18 degrees, okay? So if I want to do some math here to get the true bearing, or to get the, not true, but to get the bearing to the light, I'm going to subtract 18. Okay, so that picture helped me do that, and now I've got 048. Okay, so I can continue to draw, I can continue to use this particular diagram as the problem continues, but I'm going to start a new diagram, okay? And what I'm going to do now is, what I'm going to do is I'm just going to start this diagram over, and I'm going to go like this. Okay, so now this is the light, and I know that that is 048. Okay, now I could have kept going with this one, but I want to get away from this so that things don't get too confusing. All right, now I want to be on a course that's going to give me put that thing 4 miles on my port beam. Okay, so really, if you think about that, that 4 miles is really kind of a CPA, isn't it? Okay. So I could go to this side, and that would be 4 miles. I could go to this side, and that would be 4 miles. So this radius of this circle represents 4 miles. That's the closest I want to come to that. Well, if I put my pencil down again, okay, if I go to this side, now it's on my starboard bow. I don't want that. If I go to this side, now it's on my port side. Okay, that's what I want. So I'm going to draw it like this. Now I've got the proper triangle, okay? I've got the proper relationship of what I want to do here. And I should have drawn that just tangent to that. That should be just like that. Okay, great. So now what I can do is now I'm going to draw in. If that's going to be on my port beam, that's going to be 90 degrees, okay? So here we go. There, we're set now. So I know that this should be 4, and the distance to the object they said was 12.3. And I want this angle. So I have opposite over hypotenuse, that is sine, okay? So sine theta is opposite over hypotenuse. Another way I could say that is the CPA over the distance. The CPA over the distance. And that's going to be 4 over 12.3. And when I do that, okay, let's see, let's turn this on here. Okay, clear that. Second, sine 4 divided by 12.3, and that is 18.977. Let's just call that 19 degrees. Okay, so great. So what I want to, that angle is 19 degrees. So the question is, what course should I steer? And so that is going to be, looking at this diagram, I'm going to add 19 to 48, so 48 plus 19, and that gives me 7, and that gives me 67. I'm going to steer 067, and that's the solution to that problem. Okay?